Hi there. Welcome to this short video on Kafka. My name is Ramesh Vishwanathan. I'll be demonstrating how to achieve high availability and also how to replay events in Kafka. The demonstrations I'll be covering are number one, high availability, how to use the out-of-the-box solution from Kafka for simpler setups with one or two clusters. The second one is again on high availability for a more complex setup where you have two or more clusters residing across two different networks or two different cloud or even a combination of on-prem and cloud, and how to replicate events across different clusters. The third demonstration will be on how to replay events in Kafka. Firstly, we'll be demonstrating how the out-of-the-box solution of high availability from Kafka. So just give introduction to the key concepts and do a demo of creating clusters, topic parts, and messages using CLI of Confluent, and also be setting some configuration parameters. Essentially, the Kafka cluster, which is a set of brokers, can reside on the same virtualized server in Docker containers or can be on pods across machines or even be across multiple physical servers. Essentially, high availability is achieved if the brokers are distributed across pods and across VMs or physical servers. So when one broker goes down, other brokers come into action. So the key settings are the min in sync replicas. Replicas is the number of brokers that should be in sync for a given topic. The value of two implies two brokers are in action, and usually one of the first one is all the leader broker, and rest of the brokers will follow brokers. The replication factors uh, setting tells us how many servers it should replicate within the given replicas. Acts is an important setting from the producer point of view. When the ACK is zero, no broker sends acknowledgement to the producer when the message is committed to the broker. And if ACK is all, for example, all the replicas need to send an ACK to the producer for the commit to be confirmed. In essential, if ACK is all and replication factors n and replicas is n, uh, we can tolerate n minus m brokers going down, essentially leading us to high availability. Pictorially, if you see, consider a topic A and it has two partitions, partition 0 and 1, but it has three brokers in the cluster. Um, the replica for topic A, partition 0, can be broker 2. As you see in the middle of the picture, it's a replica at the bottom, topic A, it's a replica of topic A, partition 0. And similarly, in broker 3 can be a replica of topic A, partition 1. We'll now demonstrate how this set up the high availability within a cluster. So we'll be using confluent.io. So I already created an account. So I'm just going to log in to the account via the Confluent CLI. So the first step is to create an environment. And the command to do that is Confluence environment, create test environment. I would say one. You need to note down the ID of the environment. Now I'm going to create a cluster. And environment ID, I'll copy from here. I'll say test cluster one. We got all the details of the cluster that is created. Now we'll create a topic. Start with number of partitions as 2. And I'll call the topic as test topic 1. And I'm going to put my environment ID for the environment. I'm also going to put the cluster ID. So this should create a topic called as topic 1 with partitions 2. Now we want to kind of see what's the settings for these topics, for this topic. So I'll say topic, uh, topic describe topic one. So here are the settings for the topic. You can set this at the broker level when it comes to replications. So the key things to note are here the number of partitions, which are given as two, and the minimum in sync replicas, two. So now we can change these settings. I can change the number of replicas and partitions, for example. So I need to create a config called topic config any text file, and I set the replicas as six. I mean partitions as six and the rest two. Will save it? And now I can run the config command, which is in copied here. Um, so it's a Confluent update topic. I need to get my IDs right. So now it's going to update the settings of this topic uh, to the values given here in this config file, which is number of particles, six is replicas is two. Now it has changed that. So now I'll again describe the number of partitions is changed to six and replicas is two. So now we are ready to send messages to the topic, and that internally the brokers, the leader broker will copy that message to the follower broker. In this case, it's two, so it'll copy to one other broker for that particular partition. So, so now I'm going to my Confluence page. So I refresh this. So I got my test environment one, and it has got tested cluster. I'm going to go to the topics. And currently, there are no messages in the topic. You can see the configuration here, and you can the number of partitions. It's a six. The min equals two. Min in sync replicas is two. Now I can go start adding messages. So I'm going to add a simple message. I'm going to have a key for my message. This is not mandatory. So my message is going to be a transaction saying um, I this debit amount is $100. I'm going to send this message. So now this message has been produced. It's at the offset zero on partition three. So now I'm going to put another message. This time I'll have a key of two items. Credit amount is $55. Now it's produced and it's in partition two. So now I'm going to produce another message. I'll just copy this same key for the first message. Here I'm going to say another debit of amount 160. Partition three. So for partition three, there are two messages. So typically these two messages would have been replicated to partition two or partition three, four or five or six or one, since we are internally and that if this partition goes down, three or the broker leader broker goes down for partition three, you still have your data and your consumers are actually consuming it automatically. So this is I can't really show um, the uh, messages in the replica, but essentially that's out of the box solution that you get. So messages being replicated across brokers from the follow leader broker to the follower brokers. Now we'll see a more sophisticated setup of high availability where clusters exist across networks or even across different clouds and across even on-prem and cloud. So I'll be using the concept called cluster linking, where you link two clusters as a source cluster and a target cluster. So the advantages of cluster linking is that you get an exact replica of your source topics with the offsets preserved so that your destination consumer can actually start where the source consumer left off. There are no duplicates. The only disadvantages of cluster linking is that the topic names have to be same, which is not kind of desirable if you want to have extended solutions using this kind of cluster linking where you can filter topics, filter messages, and add them to a new topic, etc. For those, we have a concept called Kafka replicator, which you can use. But for now, we will just do cluster linking and demonstrate availability. So I have created a new environment called test environment one, and you can see I've created two clusters. The source cluster is the test cluster one running on AWS in US West 2 region, and I've also created a destination cluster in Azure in East US. So we'll see how the messages are replicated from AWS to Azure clusters. And the requirement is that the destination cluster should be a dedicated machine, not a virtual machine. Now just check the messages in our source cluster. So that is test cluster one, test topic one. And there are four messages, uh, three on partition three with offset 0 and 1, 2, and one on partition two. So now we'll see if these get replicated to our destination cluster via the cluster link. Now let us create the cluster link between these two clusters. I'm going to select my environment and my source cluster as test cluster one. And I'm going to continue. I'm going to select my destination cluster, which is cluster one dest copy. And I'm going to set some configuration. I'm going to enable the replication for all an existing and future cluster topics. I do want to add a prefix, say like a dest something. Then I want to definitely sync my consumer offsets so that the existing and future consumer groups will start working from where the source cluster consumer groups are left off. And let's continue. And let's give a name for the cluster. Yes, start link 0. So it shows here that test cluster one from AWS will be replicating its messages to Azure. So I'm going to just go ahead and create the cluster link. So the cluster link is created. Now I have to add another topic. So I select the only topic that I have in the source cluster. So now you can see the destination topic has been created with the prefix underscore test, and the mirroring is going on, is on. So, so let's see if the messages have come in. So you can see the four messages that were there on the topic in the source cluster have been replicated. So I got three messages on partition three with offset 0, 1, 2, and one message on partition two with offset 0. So now let's go back to our source cluster and add a message. So go back to our environments, test environment one, test cluster one, go to topics. So now let's add a message with the same key as one. So we have the same partition. I'm going to just make it a debit of $550. Produce that message. See the message has been produced. Now, if you go to the cluster link or the destination cluster, you will see that the message has been replicated. You can see our message with key one on partition three, offset three, amount of $550 has been replicated. So we have seen how topics can be replicated across clusters, across multi-cloud or across networks using cluster linking. There are other two ways in which you can do replication in Kafka. One is called make mirror 2, and that is the Kafka replicator. The benefits of this kind of replication is you get high availability active to active. Also, you get a DR setup active to passive cluster. And the other advantages is that you can use it for as a centralizing events and message manage messages and manage the whole set of events in a centralized way. Also, you can have many to one cluster or one to many cluster, or you can forward data from one cluster to another, chain of clusters, and so on. So this helps in also in cloud migration and modernization of moving to Kafka in general. So what I've demonstrated is using Confluent IO and also using the Confluent UI to set up easily the replication of topics and messages. We can also do all this using the Confluent command line interface. And of course, you can do all this using Kafka if you're not going the Confluent route. Confluent CLI is a wrapper around the Kafka CLI. Now I have a topic called bank transaction topic, which has credits and debits. And I put five messages. So I come to the third and the final topic of this demonstration, where I will show you how to replay events. Every topic, every partition and topic, for every message, there is a number called offset that is tagged with each message or event. And if you want to replay an event that's already been consumed, a replay event in the past, all you have to do is move the offset to that offset number of the event and then consume from there. I will demonstrate how to read all the messages from Kafka topic on a certain partition. Then I'll show you how to read a message or an event from a certain offset. Um, so here I'm using the Confluent Kafka topic consume command line, and I'm going to read all the messages from the beginning of the queue for partition 2. So I see there are three messages in my partition 2, which I can confirm from here. So you can see here that I have three messages on partition 2, and with the offsets of 0, 1 to my latest message, that is the end of the queue, is a transaction of $199 for a debit. So now I'm going to seek the last event that came in. I'm going to replay that event. So all I have to do is, instead of saying from beginning, I have to consume from my offset. So you should see that transact one single transactions for amount $199 and type debit. So that's what you see here, 199 in debit. So successfully I've gone back in the past and now I've replaced a certain event using the offset number. So that's the end of this demonstration. Thank you.